Okay, the solutions for the review mock exam for, oops, it says vector applications, but actually it's differentiation, right? Differentiation. Okay. So, first they give you a function, an x cubed blah 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 function. It's going to give you a hint. It's going to tell you to expand x plus h cubed, quantity cubed, because it knows you're going to need that later. Remember, you can expand this using Pythagorean theorem, or not, using Pascal triangle. So 1, 3, 3, 1, because it's a third order function. And then we put x to the fourth, x to the third, x squared, x to the third, x squared, x to the first. And then we'll put h to the third, h squared, h, and nothing. Add all these together. Okay? We can erase the ones, right? Okay. All the ones we can erase. All right. Now we're going to use the limit formula to find the derivative. To show that the derivative of f of x is 3x squared minus 4. Okay, so let's write out the formula here. So we're going to have f prime of x is equal to the limit as h approaches 0. And first we're going to have f of x plus h. So f of x is this expression here. So we're going to have x plus h cubed minus 4x plus h plus 1. So that is f of x plus h, slightly expanded, right? And then we're going to subtract f of x, which is just x cubed minus 4x plus 1. And then that's all on top of h. And we can't just put h equals 0 in there now because we have h in the denominator. We have to simplify this more, so we get to the point where there is no h in the denominator, and then we'll be able to substitute in the 0 and we'll be done. Okay, so that pink part corresponds to minus f of x. Now we're gonna expand further the brown part, because we know that x plus h cubed, which is this part here, becomes the expression that we have above here. So we're going to take this expression and we're going to copy it downstairs here, and we're just going to make it smaller so that it fits. Okay, so that's the first part of the brown part, and then we'll expand the rest, which is plus 4 or minus 4x, right? Because it's minus 4 times x minus 4x minus 4h plus 1. And then we're going to write the pink part out, which is minus x cubed. I'm going to distribute the negative sign, plus 4x, and minus 1. Okay, now I'm going to use the blue color, and I'm going to cancel out things that cancel out. X cubed minus x cubed cancels out. 1 minus 1 cancels out. Minus 4x plus 4x cancels out. And what we're left with is limit as h approaches 0 of 3x squared h plus, one thing I forgot to say. All of this is over h, okay? The limit as h approaches 0 of 3x squared h plus 3x h squared plus h cubed minus 4h. And each one of these things is divided by h. Okay, and then simplifying, these h's cancel out, that cancels out, this cancels out, leaving an h squared, okay? And then we're left with the limit as h approaches 0 of 3x squared plus 3xh plus h minus 4. And then anything that has a h in the numerator becomes 0, because we're going to substitute h equals 0. And then we're left with 3x squared minus 4, which is what we were looking for in the beginning. Okay? The tangent to the curve of f at the point P1, negative 2 is parallel to the tangent at a point Q. Find the coordinates of Q. Basically, when you have an x cubed function, it kind of looks like this. Okay? And it says the tangent to the curve of f at point 1, negative 2. So maybe let's say that 1, negative 2 is right here. Okay? And then you have a tangent, and then I'll draw the tangent line in green. The tangent line goes kind of like that. It actually touches right at that point. Okay? And then it says there's another coordinate besides this one, which is P. There's another point Q, which also has a tangent line that's parallel to that. And so you can imagine it's like this one here. Okay, so that's the point Q. So this is the gradient function of the main function here, 3x squared minus 4. What exactly is the gradient of this tangent line here? The way we figure that out is we just go ahead and substitute in the 1 into x. So we have 3 times 1 squared minus 4, which is 3 minus 4, which is negative 1. So the gradient of this line is negative 1. So the gradient of this line, which is parallel, is also negative 1. So you can see like the lines that I drew are not accurate because the lines that I drew have a positive slope. The line here needs to have a negative gradient, but you know, just the idea that there are 2 points with the same tangent, that's what I'm trying to draw here. Okay? So what is the other x coordinate which has a gradient of negative 1? So let's see, let's do some algebra here and isolate x squared. So we're going to add 4 to both sides, and we're going to get 3x squared equals 3. Then we'll divide both sides by 3, and we'll have x squared equals 1. So now we know that x is equal to plus or minus 1, and we already found the negative 1 solution, so the other solution is just positive 1. So the q coordinate would be positive 1, and then the y coordinate we could find by putting back in the original function, which, if you remember, is x cubed minus 4x plus 1. So we'll do x cubed minus 4x plus 1. Let me make sure I wrote that correctly. Yes, it's written at the top. And I'm going to put 1 in there, and I'll get 1 cubed minus 4, 1 plus 1. And so that's equal to 1 minus 4 plus 1, which is negative 2. So the q coordinate is 1, negative 2. Okay? So we found the coordinate for q. Now, the graph of f is decreasing between 2 points. Find the value of p and of q. Okay. Let's see. The graph of f is decreasing. That's just another way of saying that the gradient of the function is negative. So let's see. When is the gradient, 3x squared minus 4, less than 0? Well, the first thing we're going to do is we're going to figure out when this is equal to 0. 3x minus 4, when is that equal to 0? So we're going to add 4 to both sides. We'll get 3x squared equals 4. And then we'll have x squared, we'll divide both sides by 3, and we'll get x squared equals 4/3. And then we'll have square root of both sides, and we'll get 2 over the square root of 3. Okay. So, and I'm sorry, it's not just x equals 2 over square root of 3, it's x equals plus or minus 2 over the square root of 3. Okay? So, the values here of p and q, one is going to be negative 2 over square root of 3, and the other one is going to be positive 2 over square root of 3. Okay? So those are the values that give you a 0 gradient. In between those two values, it's going to be a negative gradient. Okay, and just to test that out, if you put a value in between these two, such as 0 into the gradient equation here, if you put 0 in there, you're going to get a negative number. So, like, we could make a little line number graph, and we could mark this, okay, negative 2 square root of 3, positive 2 square root of 3. In between these two, it's negative. Out here, it's positive. Because if I put a 0 in, remember, I get a negative number. If I put a big number like 100 in there, then I'm going to get a positive number. If I put a really low number like negative 100 in there, also get a positive number. Okay, so they ask, when is it decreasing? It's decreasing in this interval here, between negative 2 over square root of 3 to positive 2 over square root of 3, which are the 0 points. Okay. Write down the range of values for the gradient of f. Okay, so if we look at 3x squared minus 4, what is the smallest value that can be attained? Well, no matter if you put a huge negative number in here or a big positive number you get in here, it's never going to be, this part here is never going to be smaller than 0, right? The smallest you can make this, the lowest value you can make it is 0. Okay, so the minimum value is going to be 0 minus 4. The minimum value of the function is going to be 0 minus 4, which is negative 4. Okay, so this is the minimum value. What's the maximum value? Well, you can make this as big as you want. You just put, a million in there, and it's going to be even bigger. You could put a billion in there, it's going to be bigger. So the maximum is infinity. Okay, so the range of values for the gradient of f would be, it's greater than or equal to negative 4, and it's, ranges up to infinity. Okay? All right, moving on. Number 2. Let f of x equals x cubed. The following diagram shows part of the graph of f. Okay? So basically we have a tangent line right there. It touches the graph at this one point, and the coordinates are a comma f of a. So we don't know what the coordinates of the tangent line are yet. The only thing that we do know is that the tangent line cuts the x-axis at the coordinate q, and it cuts the function again at the coordinates negative 2 comma negative 8. The first thing it asks us to do is to find the gradient of the line P, or the line segment PQ, which is the blue coordinate and the brown coordinate. Okay, so to find the gradient between 2 points, it's just the y2 minus y1 divided by the x2 minus x1. So the blue coordinates would be y2 x2, and then the brown coordinates would be y1 x1. So let's fill that in. So y2 is f of a, y1 is 0, x2 is a, and x1 is negative 2/3, right? And then that gives us f of a divided by a minus 2/3. And remember, f of a is just a cubed, right? If we put a in for the x, we get a cubed. So we have a cubed divided by a minus 2/3, which is exactly what we were supposed to find. Okay, then it says to find f dashed a. So they want us to find the derivative or the gradient of the function at point A. Okay, and we know the function, it's x cubed. The derivative of the function is 3x squared. If you remember, you could use first principles, or you could just use the power rule, which we inferred from our investigation. So f prime of x equals 3x squared. So f prime of a is just equal to 3a squared, right? So we can put that in here. We could put equals 3a squared. Okay. Then it says, hence show that a equals 1. Well, how do we know that? Well, actually, we know that because we know that this is the tangent line at x equals a. And if that's the tangent line, then the gradient of that tangent line is equal to f dashed a. So we know that this is equal to that. Okay? And if we know that that's equal to that, then we can just set everything equal. 3a squared is equal to a cubed divided by a minus 2/3. Okay, now we can just use algebra and figure out what a is. So, for example, we could divide both sides by a squared, and we'll get 3 equals a divided by a minus 2/3. And then we can multiply both sides by a minus 2/3 to get it in the numerator, and we'll have 3 times a minus 2/3 equals a. And then we can multiply the 3, distribute it, we'll get 3a minus 2 equals a. And now we're going to want to subtract a from both sides so we can get rid of a over there, and then we'll get 2a minus 2 equals 0. And then we're going to add 2 to both sides to move the 2 to the right, and we'll get 2a equals 2, and then we can divide both sides by 2, and we just get a equals 1, which is what we wanted to get. The end.